So you can also use, there's an object called tab1, which is our table. If you remember the result of our table, we say is tab1 equals to tab into hours work, GTAT, comma, mental health, something like that, severe MH. So that object is kept. So how can easily record? You can summarize that tab to, it will give you the same thing. You can use summary also to get the same thing. You are testing for, you have your chi-square, degree of freedom, and your p-value, the same thing. It means that you can do this too. Then how do you interpret the findings? We've actually interpreted the findings. The same scenario. Now let's see what we can achieve with logistic regression. Logistic regression can help us to estimate. With logistic regression, if you remember, we can adjust for confounders. You understand? Maybe, for example, we are looking at number of hours worked and severe mental stress. For example, does level of seniority among resident doctors, does it have anything to do also with development of severe mental stress, or even with the numbers of hours worked? I'm sure they will have told you about confounding if you go back to understand what a confounding is. Or for example, age. Some resident doctors might be 50 years old. Some resident doctors might be 20 years old. Does differences in age, does it have anything to do with the estimation we are seeing, with what we are seeing, the odds that we are seeing? Odds is the way we are estimating, the relationship for logistic regression. You may want to, as a scientist, you may bother about that. You may also be bothering about things like the number of children that these resident doctors have, or even the gender. Does it have anything to do? Because that is how science is. Most of disease conditions, we found out that they are not caused by one thing. They are usually multifactorial. You will have heard of multifactorial causation of disease. So you must bring that domain expertise, that domain knowledge. Maybe, for example, you're a medical doctor, you're a lab person, you're a nurse, that your understanding of human biology, pathology, you must bring it into your work. The same thing is what psychologists will do when they're exploring how human minds work. There is domain knowledge. You must bring it in. These are things that, for example, a statistician may not know, even though he knows the methods. What do you want to do? Tell me. But the domain knowledge, you must also layer it up on statistics. I'm a medical doctor, for example, but I know a bit of statistics. But, when I'm talking to a statistician in my workplace or the programmers, I bring my domain knowledge. I bring my, I understand all these things, but they understand very well modeling. They understand all these statistical analysis. So for you as health workers, you must bring that domain knowledge. So that's where you want to know about confounding. So this is what a logistic regression can help us to, take care of that a chi-square may not do. Now let's go into logistic regression. So it's about modeling. We want to use the data to create a model, and we can use that model to test how useful it is for us to make predictions, to establish relationship. That's what you are doing with regression. That's what regression does. Create a model, then you can use the best line, the best model. You try to look for the best model. You can use it to predict, to explore association between one variable and the other, and stuff like that. So let's start here. We're saying we can change this model 5A. It's just, you can say model A is just an object, just to give it a name. You understand? So it's nothing. So we are saying model 5A, but GLM is a specific function. You could see, can you see my computer? This is what I wanted to show you before. You could see the yellow box. This R is trying to give me, R is trying to give me what I would say, like defining GLM. R knows what GLM is. Then this is the original, definition of all the elements. The first thing is you put in the formula. Can you see the yellow stuff on my screen? Please quickly.
Yes.
So this R is guiding me. This is what I wanted to show you the other time, that you can try and understand. Then the formula is the first thing. That's what R is saying. Put your formula. Here, our formula is severe.mh, which is our outcome. What is his relationship with hours worked? That's the formula, comma. And that's what we've written. You see that if you look at my yellow box, R is saying, if I take my cursor away, it will go away. If I take it, it's gone. Just to show you. So those are the trick for you to, learn. The next thing is, what family of generalized linear model do you want to use? that's family. I can move it around. I say my family is binomial. You will have learned about binomial distribution. The common thing is they say coin. When you toss a coin, there are only two possible outcomes. Then you can pay the trier. So the family of generalized linear model we want to use is binomial. And that's what we are specifying here. Family is equal to binomial. Probably what you have, they will say link is equal to logit. Those are like, is already pre-specified. If you delete it, it's still going to work. But in some instances, you may want to change it, even though binomial, but you don't want to use a logit. Link is equal to logit. But it's the same thing. But importantly, it's binomial we want to use as a family. Then you have to specify your data. If I go back to, you have to specify your data. Then a lot of functions that the default function is what you are using. We don't need to specify it. NA.action, it means something. All these ones, control, list it, method, X is false. Why? You don't need all those things, but some instances you need it. This is enough. Then you have to specify where the data is coming from. If you are picking this variable severe.mh and hours worked, you want to see their relationship, and that's what theta means. This sign theta. That's what we mean. The outcome variable or then how does it and the predictor, which is hours worked, you specify the data, where is it? You find it in RDS. You are telling how this is where you have, because some instances I may load 4 data like somebody already did, and instead of seeing RDS here, you may be seeing this on the same R studio. So I have to specify to how where R is going to find it. So that's what we did here. Data is RDS, then family. Then use summary to bring out the result. I could run it one after the other, or I could run it together. But because of time, I'll run it together. I'll run current chunk of R. Then this is the result. Either you look into your console or just below your. So call is just calling back, the result is telling you these are the residuals. By now, you should know what residuals mean. Residual, we already have a model now. Residuals are like more like error. Individual data point, how far are they from maybe the baseline of fit, the slope, or that the R is giving us the model. Then coefficient is very important. By now you should know what intercept is. Intercept is like the value of the outcome variable when your independent variable is 0. That's what intercept means. And hours worked is we have the two categories of is the numbers of hours worked, and this is the estimate minus 0.0411. But in logistic regression, what you are seeing here is they should have taught you this. I don't know whether they've mentioned this to you. Is logs of the odds. This value you are seeing is log of the odd. For you to get the odd ratio itself, you have to exponentiate it. That means, did they mention this to you?
Yes.
Okay, excellent. Then I can move forward. You have to exponentiate it. That's the next thing. How does not automatically output the odd ratio? You have to exponentiate the model result. And this is what we are doing here. Exponentiate it. cbind is a function in R. It's called column bind. That means I'm saying my odd ratio, create a column called odd ratio, then bind it with the confidence interval. I could also just stop and say, please I could also take out this. Then I want it 3. And run this. It's going to give me something wrong. I need this. When there is a red asterisk beside, that means something wrong with your code. So it's fine. I could run this. It will give me my result, but it's only going to give me the odd ratio. If you do this, let's do it for example. You could see I have only the odd ratio. But I could also add to it, sorry. I could also add to it confidence interval, confit, like you have confit, comma, model 5a, the same model, but you have to put a comma. So it's going to, if I run it again, it should give me the 2. You see, I have my odd ratio, I have my confidence interval, which runs from 2.5% to 97.5%. It means 95% confidence interval. That's what this means. That means I have my odd ratio now, which is 0.959. And my confidence interval runs from 0.932 to 0.984. I'm sure you also know what confidence interval is. There, we are 95% confident that our odds ratio is between 0.932 and 0.984. So how do we interpret this? It's important we interpret this.
We'll now minus, hello?
Yeah, please go on. Please go on, please.
Okay, the
Hello, can anybody hear me? I think we lost him.
hello?
Yeah, we can hear you now. Please go on.
Yeah, to interpret it, we now say the exponent we got here, we said 1 minus 0.95 to give us 0.055. So we now said that we do it we can express it in percentage.
Excellent. That's it.
So we now said that the odds of mental health so I'm listening. Okay,
let me
are less likely.
Yes. Yeah. Can you do you get it? Go on,
yes,
please.
I'm trying to put it in the right way. Okay, the mental, as the number of hours worked increased, the likelihood of mental health to the mental.
Yeah, let me help you. Don't worry. I know that you know it, and I know where the small confusion is coming from. You know, our predictor is continuous. Unlike what we did with chi-square, hours worked, we did not use the categories.
Okay.
Let's look at the model again. Let's look at our equation. I get that now. See, I use severe.mh, which is the binary categories. I did not use hours GTAT. I use hours worked, which is this. Where you at? So I will explain hours worked. You could see is the continuous that we use. And to explain this, to interpret this, is saying, oh, I passed it. Just a minute. Okay, I think we are here. Yes. Okay, so the interpretation of this is that your interpretation of the 0.959 is correct. But in relation to hours worked, it's going to say that for every unit increase in hours worked, there is a 0.95, 0.96 time odds, or we can say in percentage, that's 4%. For every unit increase in hours worked, there is a 4% decrease in the odds of developing a severe mental stress or a mental stress. Okay. Is that correct? Is that understood?
Yeah, thank you.
Excellent, because our predictor is quantitative. So you have to use unit increase. That's what this means. If you've used the other one, which is the categories, you have to use maybe less than 80 as a reference and greater than 80 as the test, it will have come out. Then we'll have said that those that worked more than 80 hours per week, for example, have 4% have a 4% less odd of developing severe mental stress. Or we can say those that work more than 80 hours per week have 0.96 odds, likely less odds of developing mental health stress. Those in the category that work more than 80 hours per week are 4% less likely to develop mental health stress compared to those that work less than 80 hours. Is that clear?
Yes.
Thank you. So, but because here is just hours worked, so you have to use unit increase. For every unit increase of hours worked, there's a 4% less likelihood of developing severe mental health stress. That's a, and I put this there just to show you that you can also break your exponentiation down. You can do it separately. You can check the coefficient first, without using cbind. If I run this, let me just run this separately. Let me run the two. And you can see it. This is the first. the odds ratio, and this is the confidence interval. But what C might just do is just to combine it for you. So whatever, because why I put this there, it may be easy for you to just say exponentiate my coefficient of model 5. It's very easy. This is very easy. So if you are writing your code like this at the initial stage, is fine. But the more you know how, you know that instead of going through steps, you can just combine it like this and specify what your odds ratio is. And you could see, because I did not define odds ratio, it just gave me the value, hours work, but you must know it is odds ratio because you are already exponentiating it, your coefficient. Exponentiation of the coefficient is equal to odds ratio. Okay, is there any question at this stage? Logistic regression, and you can see that the major difference between what we've done here is that we've quantified how much of the relationship. We are talking about 4%, we are talking about 0.959. That is a step higher than what we got from chi-square. Chi-square only told us that there is a relationship, but by what's the estimation? There was no estimation. And here we have an estimation. And let me quickly show you something before I go. And from our result of the logistic regression, there is also p-value. And this is it. Let me use my stuff.
It's somehow close to that of the chi-square.
Yes, it is. So you could see that here too, we have to reject the non-hypothesis. I already jumped it. We've rejected the non-hypothesis. That means there's that. We know that from the chi-square. Or even here, you could see if we've done this way, oh, okay, so there's a relationship. You already know that there's a relationship, you know. Then you go and specify what your odds ratio is to interpret. Any question at this point, guys? Please feel free if you have any question, we can ask. Because if you get it where, you know, every other thing is just a modification. Every other thing we do now is just a modification of what we've done. Any question? Anybody? Okay, I assume no question, so I go on. So, you know, what we've done is just one variable predictor, one predictor variable, and the binary outcome, and the outcome variable. You could do that. You could also do a multiple logistic regression, sorry, where you explore the association between, or the relationship between multiple predictors and your outcome. And we are talking about confounder the other time, you know, effect modification, which maybe they've mentioned it to you, a third variable that could, you know, explain what we are seeing in our model, or the effects or the results or the estimation that you're getting in terms of odds ratio. And so you handle this with multiple logistic regression. It's also known as multivariable logistic regression. Logistic immediately tells you that the outcome is binary, it's a binary variable. Sick or dead, survive or dead rather, it worked or it didn't work, maybe if it's a drug, you know, so two outcomes, that's binary, that's logistic. So you can see here the same model, I changed the object to B because R is storing this model. This model is just like, you know, it has used the data we gave it to create a model for us, and we can use the model to predict. So we are creating another model. We are using generalized linear model. Again, our outcome is still severe.mh. Then our independent variable, predictor variables, just then use your sign. That sign is saying, please explore its relationship with this independent variable. The other time we use just one. Now we are saying include hours worked, include the female variable, and this female, I will have changed it to gender. You understand? It actually means gender. If you come back, you could see this female doesn't mean that everybody is female. 1 is female, 0 is male, 1 is, so I will have changed it to gender, left to me. So it means gender. Then you're including the age is there. We're including children, this variable children, maybe number of children, I assume, yes, 0, 2, 0, 1. These are individual observations. Then you so you could see plus. The only thing that changes is that compared to the former one, when you start specifying your predictor variable, you have to use plus, plus, plus. Then when you're through, comma. Then you specify where you will find all these variables. You have to tell R, RDS. Then work family is binomial. I just intentionally left this because you have it. I deleted the other time to show you that you could leave it, because I know that link is equal to logit is the default link that is there for binomial in R, unless you want to change it, and you will sit down when we need to change it. So because I'm still using the default one, it's still, I can delete it. It will still work. I can leave it. It's the same thing. I will leave it this time around. So I can run the entire code with just one button, the current chunk, or I could go line by line. So for this time around, let's go line by line just to show you guys. I'm not sure if you already know that. So I'll go line by line now. So I'm running that first line of code. R has processed it, as you can see from my console. But if I want to see the result, you have to use summary. Tell our summary of model that you've created. I run the selected code, and now it has come out. And like you know from the other time, we can only see is this significant? We can't see, and we cannot see the odds ratio. We can only see the coefficient. Is the estimate. That's what I mean by coefficient estimate. So this is the logs of the odds. When you run a logistic regression model, you will get the log of the odd. That's what you get. That's your output. You have to exponentiate to convert it to odd ratio. So now let's look at this. Is this, you can see the p-value. That's what I want you to pay attention to, and forget the intercept. The p-value, the only thing that is significant here is hours worked, the relationship of hours worked on the outcome variable. See, mental stress is the only one that's less than 0.05. So I already know from here that gender, age, children does not impact the relationship I've previously established between hours worked and development of severe mental stress. So I could conclude that at this stage, female, that there is a significant relationship between hours worked and severity of mental stress as an outcome, even when I have controlled for gender, for age, for number of children. That is the conclusion. I can conclude there at this stage, but I cannot say I can't quantify that relationship. To quantify that relationship, you need your odd ratio, and that's why you have to exponentiate. It will have come out if I've run the code as a whole, but so this should not be strange to you. The coefficient will give me the odd ratio, and confit will give me the confidence interval. And you can see here, my odd ratio is 0.959 for hours worked, and I have the confidence interval. Is that clear? It's just the same thing we did the other time. It's just the same thing we did the other time. So what I would do now is delete this and run the entire code together so that we have complete results to look at. Do you guys appreciate this? And I want somebody to interpret it. Please factor all. I've already said interpretation, but you can say it again. Factor all this and add this odd ratio. Anybody, please. Just try. You don't have to get it. And if you get it, excellent.
Please come again. Let me.
So
come again.
We have the results, and these are our results. Let me go back to our model. Let's call our model. Our model is JLM. These are formula, severe mental health. Yes. Then we are testing.
I have that. I've run that one.
Okay. Then I said, please look at these results. Look at this. Okay. Look at the p-value especially, and which of the p-value. Look at all these are p-values: 0.00349, 0.754 for gender, for age. You can see the p-values. Okay. You can interpret that. Then add onto it the odd ratio for hours worked. You can see the odd ratio to interpret it.
Okay. Sorry, I want to do the 0.96.
Please take your time.
Okay. For every unit increase in for every increase in hours worked, there is the odds of having severe mental health issue of 4%. 4% odds of having severe mental health issue, while controlling for, and is statistically significant while controlling for gender, age, and number of children.
I will give you very good. Yes, you are correct, but it's not 4% odd. It's 4% less likelihood of the odds. It's 4% less. If it is 1.32, it is 32%, higher likelihood. You understand? So it's not 4% of the odd is not the odd is actually 0.959. So if you say there is a 0.959 odds, of for every unit, So for every unit increase in hours worked, there is a 4% less likelihood of developing severe mental. So this result is suggesting to us that the more you work, the less your chances of developing severe mental health. It may be counterintuitive, but if you look at it from exercise point of view, maybe it's a form of physical exercise, walking around. If it's, I'm just guessing as a doc, we already know that, there's an association between physical activity, if they are physically active, and mental health. We know that there is some sort of correlation, positive correlation. The more physically active you are, the better your mental health. That's the anecdote in medical literature, in science. So the interpretation of this is that there is a 4% less likelihood of developing severe mental health for every 1 hour, for every unit increase in hours worked, while controlling or while adjusting for gender, age, and children. And this is not useful because the p-value is more than 0.005. So we can say female has no, gender has no association, age has no association in what we are seeing. Do you understand? But because for hours work, it is significant. So it tells us already that we have to reject the null hypothesis. But for gender, age, children, you cannot reject the null hypothesis. Is that clear? Any question, guys?